Hi, this is Dilip. I am from third year CSC department. My register number is UR16CS094. Today our lab experiment is about 2-pass assembler for simple instructional computer. 6 stands for that. Our aim is to simulate the concept of single pass assembler for simplified instructional computer. Description. As I once go through it, you can easily understand. An assembler is a program that accepts a input of source program and converts it into an object code, which is machine language equivalent, along with the information for the loader. Advantages of coding in assembly languages are provide more control over handling particular hardware components, may generate smaller, more compact executable models, often results in faster execution. The algorithm for the creation would be open and read the input file. If the input line has the opcode start and we need to convert, and these are the steps for that. Write the input line to the intermediate file. Do the following steps until the opcode is end. If the opcode is end, we are going to end that. When you get into the code and explain, you will easily understand that. And these are the steps for all those things. To find the length of the program, subtract the starting address of the program from the location counter LC. Close all the files, and the sample input and output would be like this. This is the name of the file, program, and this is the start, and this is the starting address of that program. Load the accumulator with alpha, and this is the program. And these are the labels for this. These are reserve word, and end. And opcode table has symbols. As you can see that they are defined, and symbol table contains those. And symbol table contains the labels that have been defined, and result table contains the header record, text record, and end record. H stands for the T and E. Header record contains the name of the program, starting address of that, and length of the program. And text record contains the length of that line and where it starts. This record where it starts, and this is the 6 byte record, and the text record has ended over here, and end record contains the last where the program gets started. This is the end of that program. Our question set is about a write-a program to simulate a 2-pass assembler. Let's get into the code now. I have been doing this in Java, NetBeans. I have created a package called assembler and imported all the required Java input output buffer reader for reading and writing, file reader and writer, and input output to handle the exceptions. We have this thing, and hash table to use the hash table. And I have created a class called assembler. Under the main function, I have been using throws exception to handle the exception. I have created an object for hash table class, and this is the function. And of length 30 I have been creating, and through buffer reader I am gonna, as you have seen here, I have included a path. The simple way of including the path is to click on to paste this file over here, and wherever the package has been program has been stored, get to the properties, simply copy this thing and paste over it. It will be easier for you. And this is new buffer reader to read the content, and writer to write the content into. I have been reading the content from the symbol table, input table. You can see that input table has this program, and our output would be in the symbol table. I would be writing it into symbol table. Our output would be displayed over here. I will show at the end. And we have created a string or data type line and title, and this is empty, and I have incremented the location counted as 0, and at the same time start as 0. Since I have incremented over here, initialized over here, so no need to initialize it again in the for loop, and I have been reading that line. If it is not equal to none, if it contains start, then I am going to get into the loop. I have created an array name C of the string data type, and I am going to split wherever there is split. I am going to take it into array. If it is equal to 3, then the integer I am going to get into the array of 16, and we are going to start else. If it start equal to 0, then location counter would be set to the start, and I am going to write this in length equal to LC minus start, then location counter would be set to start, and I am going to close the read section is for buffer reader close. I have created a BR as an object to the buffer reader class, and WR as the object to the buffer writer class. And I have created this is the public private. As we know that these are the helps us to who want to access the inside the content. If it is public, everyone can access it. If a private, only that part of the class can be accessible. If it is protected, only the child class can access it. As we already know that, I have created a string to 6, and if it is we are using the word dot length, we are going to get the length of the word. If it is less than 6, then we would keep in front of it as 0, since it is 6 byte, and plus word, since the word would be only of 4 byte over here, so we will keep 2 more zeros at the starting. And these are the code to check, and these are the conditions. As we see that here we have keywords, word, reserve word, reserve byte. If these words are given, then we are going to calculate that space and give that amount of space to that. And hash table, we are handling exception again using the throws, and I have created an object to the hash table. OP is the object to the hash table of length 30, and using the buffer reader, I'm going to read from the symbol opcode table. In opcode table, we have over here these two, and when we run that, we can easily understand that. Here we got the header record. This is the name of the program, and this is the starting address of program, and this should be the what is the length of the program. Length of the program, as we already know that it is calculated using this start address minus and total length of the program. We are going to get this. This is end record and text record. Thanks for watching my video.